Hello, today we're going to talk about topic 5, section 3, derivatives of power functions. So here you've got the power rule, and hopefully it makes sense. If it doesn't, it's really simple. So for A, what we're going to do to find the derivative of f is we're going to take the exponent and put it out front. So it becomes 2x, and then we take the exponent and do 1 less than it. So here, the derivative function is 2 times x. Simple. Part B, the derivative function here. You put the exponent out front and decrease that exponent by 1. So you get 5x to the 4th. Last one. Yes, it's really that simple. 220 times x to the, why did I say 2? Here I am, so simple, and then I'm stumbling on my words. 2021 times x to the 2020. Alright? Here we go. So we're going to find these. Alright? Don't overthink it. Okay? We're literally going to do the same thing as before. And this is just x to the first power. So put the 1 out front, decrease that by 1, that's a 1. I can write better than that. Okay, so this is 1 times x to the 0. And what's anything to the 0 power? Oh, I hope you said 1. So the derivative of x is just 1. Okay, for B, part B, we're going to do the derivative of g. And we put the exponent out front, and then we decrease that exponent by 1. But it really doesn't matter here because our exponent was 0. So we're going to multiply by 0, which is always 0. Last one. Put that exponent out front, so it's now negative 2 times x to the negative 2 minus 1, which is negative 3. There you have it. Now we do the last, or the bottom 4. Okay, so here we wanted to have a x, but there's no x here. Where have we seen that before? Oh yes, x to the 0. Alright, so our derivative function, so we can think of this as 1 times x to the first, so our derivative of that is just 1. Right? 1 times 1, and then x to the 0. Okay? So then here we have b. So this, another way of writing 1 over x cubed, we didn't talk about division, but we can rewrite that as x to the negative 3. So the derivative of that is just negative 3 times x, and then 1 less than that is negative 4. That looks like a Y or a G. I don't like it. Okay, well, a little better. Alright, part C. So, another way of writing x to the 5th over x cubed, we can simplify that and say x squared. So, the derivative of that is just 2x. Alright, part D, we can rewrite that and say x to the negative 4, 2 minus 6. So, L of x, hate using L, alright, but anyway, is negative 4 times x to the negative 5. Okay? Alright, this is the constant rule. So what do you do with the number out front? Well, I tell you to overthink it, or don't overthink it, but you're probably going to. Okay? Alright, it's really simple. You just take that, you still do the same thing. Take that 4, put it out front. Okay, so it's going to be 4, and we have the 2x to the 4 minus 1. You take that 4 and you multiply what you had. Okay, so now the answer for this, the derivative, is 8 times x cubed. Let's do it again. Put the exponent out front. Negative 3 times 5x to the negative 3 minus 1. So here we get negative 15. these through, and then I'm going to write out the answers. So I'm not going to work all these out. So this one should just be 7. Well, this one's weird. So we do 1 times 7, and remember, that was x to the first, so 1 minus that is just 0. Anything to the 0 power is just 1. So, knowing that the derivative of x is just whatever's in front of it, the constant, not constant, the coefficient, that's something easy, something you want to remember. Okay, makes things easy. This one, again, this one's weird. You can write that as 9 times x to the 0. So, when we simplify, or I'm sorry, take the derivative of that, 0 times 9 to the x, I'm sorry, 9 times x to the 0 minus 1, that 0 cancels it out. So the derivative of a constant, the derivative of a number, is just 0. Okay? Alright, so let's see, I'm just going to rewrite these to make it a little easier. And this one is just this. I would go ahead and pause it. I'm just going to fill these in. Hopefully I'm doing this all right. Okay, let's do the next one. Alright, the sum rule, okay, is literally just taking the derivative, and so if you have a sum of two functions, the derivative of that sum is literally just the derivative of each one added together. So the derivative of h, this is going to equal 2 times the derivative of x, I'm sorry, the derivative of f, minus 3 times the derivative of and then we just plug things in. We know the derivative of f is just the natural log of x, and here the derivative of g is just 1 over x. So a nicer way to write that is 2 times the natural log of x minus 3 over x. Alright, next one. So here's h of x. So h prime of x is equal to 3 f prime of x, I'm sorry, derivative of x, plus the derivative of, alright, so we want to find the derivative at negative 2, so we plug that in. X is now negative 2. Well, we have these answers in our directions. So now we have 3 times 4 plus negative 5. So 12 minus 5 gets us 7. Alright. So, for some functions, we have the graph of f has gradient at this point. Alright, so we want to show that the graph of h passes through this point. Okay, so that means that h of 1 must equal negative 54. That's what this is saying. Okay, we have to realize that's input and output. So the input of 1 must get us the output of negative 54. So when I do h of 1 up here, that must also equal 6 times g of 1 minus 8 times f of 1. Well, we've got our point values up there, so we can plug them in for f and for g. So we know h of 1 is negative 54. We know 6 times g of 1, so g of 1 is negative 5. And f of 1 is just 3. Because these are our points at f and at g. So is negative 54 equal to negative 30 minus 24? There you have it. We've proved it. Perfect. Alright, let's do the next one. So for part B, find the gradient of the graph of h at the point 1, negative 54. So now we want f prime, or the derivative of h, I don't know why I keep saying f, the derivative of h of 1 has to equal negative 54. Alright, so we know that the derivative of h, right, is equal to this. Alright, and now we want when x is 1, so we're going to change all those x's to 1. Again, this is just to help visualize it. Okay, and now we know what those values are. Let's see, the gradient there needs to be negative 54. And here needs to be, let's see, the gradient at G is 4. And the gradient at F is negative 2. So, is that the same? Oh, it says find the gradient. Ugh. I was in such a mode over here. I'm sitting here trying to do it the same way I did the last problem. Pay attention to what you're doing, Rachel. Okay. We want to find what this is. We don't know what it is. We just want to find it at this point. Okay, so this is at the graph of h, not h prime, or the derivative. So here we get 24 plus 16. So here our answer is 40. There we have it. Alright. So here's the combination of rules. So you can pause the video, take a snapshot of that. That's the, this rule is in the formula book, okay? But you want to notice that these are not, okay? So you just have to remember the ideas. And luckily, this all kind of should come at it like instinct, okay? If not, do it enough till it is. Okay, so here you've got some more practice problems. So I'm going to let you guys pause the video here, and then I will unpause it and show you the answers. So, pause. Okay, so hopefully you got these same answers. I put them all on the right side over here. I tried to show all my work on the left. You didn't have to show as much work as I did, clearly, because I know sometimes these are a lot easier. But I would at the very least simplify your answers into one equation. Like if you notice, G and H were particularly interesting because I could not take the derivative because there was multiplication. So I FOILed first. Then I took the derivative. Okay? For I and J, notice that it was division. I don't know how to do that. So what I did is I split it into two fractions, right? I divided each part by the denominator. Okay? And then I took the derivative. So, if you have any questions, let me know. I will gladly walk you through any of those. Alright, so the next part is finding the gradient of the graph at the given point on the graph. Okay? So, if I'm trying to find the gradient, well then, what should I find? Oh, I don't know, maybe the derivative. So, let's start with A. Okay, the derivative of f of x here would just be 6x minus 4. Okay, hopefully we've gotten quicker at that. The next part is we want to find it when x equals 2. So, find the gradient at 2. So plug 2 in. 6 times 2 minus 4. That's going to give you, what, 8? Keep on going. Find b. So the derivative of that equation, well, first we should probably do what? Yeah, we should FOIL that. So before I jump into that, let's do that. 2x minus 1 times x plus 3. Alright, that's going to be 2x squared plus 6x minus 1x minus 3. So 2x squared plus 5x minus 3. So the derivative would be 4x plus 5. Plug in negative 5. 4 times negative 5 is negative 20. Plus 5 gets you negative 15. Keep on working them out. C. So let's see. We have the derivative of that is going to be 2, not x, there's no more x. Alright, that's going to be negative 3x to the negative 2. So plug in 1. This is really nice because 1 to any power is just 1. So 2 minus 3 is negative 1. Alright, ooh, what color next? Let's do pink. Whew. Sorry, lucky I found that pause button. I just sneezed. So excuse me. Alright, so part D. We are going to first divide each one of those. So 3x cubed over 4x squared minus 5 over 4x squared. So really you want to visualize that as, what would that be? 3x over 4 minus 5x to the negative 2 over 4. It's easier with that numerator, or the variables on top. So the derivative is going to be negative, not negative, silly me. It's going to be 3/4. This one's going to, a negative is going to change that to a positive out front, and we're going to get 5 times x to the negative 3 over 4. Now plugging in negative 1. So we have 3 over 4 plus, well, negative to a negative 1 to the negative 3 is just negative 1. So this actually becomes negative 5/4. So our answer ends up being negative 2 over 4, or negative 1/2. There you have it. And the last problem we're going to do is the graph of this has a horizontal tangent at the point A comma B, where A is of course greater than 0. Not of course, I don't know why I said that, it just says it there. So we want to find those coordinates. Okay, so think about what it means to have the horizontal tangent. Well, that means it's talking about the gradient, okay, or the derivative. So if it's a horizontal tangent, that means the slope is horizontal, which is 0. So let's find the gradient or the derivative of y. That's going to be 4, let's see, minus x to the negative 2. So we know that this derivative function, all right, and we want our slope to be 0, so that means the y value of our derivative has to equal 0. Okay, now I don't really like that negative exponent. Well, maybe I'll leave it like that. I'll move it to the other side. X to the negative 2 equals 4. Well, 1 over x squared equals 4. Do some cross multiplying, right? You can work it out. You essentially get x squared equals 1/4. Right? If you had cross multiplied, you would have gotten 4x squared equals 1. Okay. Depends on what kind of shortcuts you know. All right, so then that means x must equal 1/2. Oh, I hope alarms are going off. Okay, that should be plus or minus because we put the square root there. We're taking the square root of both sides. We got to put plus or minus. Okay, that's what you got to tell yourself. Okay, so we have two values, 1/2 and -1/2. Ah, what did it say up here? A is positive, so our two values, okay, we're not focusing on the negative value. Okay, this is 1/2. So we want to know what the coordinates are. Well, that's our x value. Remember, the x values of a original function and its derivative are the same. So if our x is equal to 1/2, we get y by plugging in 1/2. So 4 times 1/2 is 2. Don't know why there. And then 1 divided by 1/2 is 2. So y is 4. So our coordinates are 1/2, 4. Alright, so here is what you should know, alright, at the end of this section. Hopefully that all makes sense. If not, come to class, ask me questions. Alright, see